So let's talk about types. Now, this is probably an odd question, but what is a type? What do people think a type is? Now, there's an answer up on the screen, but if I said to you, as maybe even an exam question, what is a type, what would you say to me? How would you answer that? Anyone know? Okay, that's a reasonably good answer, yeah. A defined, so if I paraphrase you, a defined way of storing, using, and implementing data? Modifying data. Storing, using, and modifying data. Yeah? Yeah, could you extend that more? I mean, that's a pretty good answer. I'll give you that. That's a pretty good answer, yeah. So you said it's a defined way, which I'd kind of agree with. So what farms we've got on the slides is a type is a set of values. Okay, so you might define a set of values. So for argument's sake, an int is actually a set of values. An int is a set of 1, 2, 3, 4, and so on and so forth. 1.2 is not in that set of values. Okay? You then have a set of operators. Okay? So plus, minus, double equals, double ands, things like that. So if you look at the very simple type here of a bool, okay, so actually in C, I don't think you have a bool. You don't see a bool in C, do you? No. So here you go, new type already. So if you look at the type of a bool, you have two values, true and false. It can't be your mum, your dog, or your uncle, okay? It can either be true or false, okay? You can't do, at least I don't think you can't do true plus false. Doesn't make sense. It does in some contexts, but normally true plus false doesn't make sense. But you can do things like double ands and double equals and not equals, okay? So true and false is an operator we can perform, okay? And true and false, of course, is false, okay? So what's a type? It's a set of values, it's a set of data values that something can be, and then it's a set of operators that can operate on them. Okay? So we have some basic C++ types. We have bool, we have character types, okay? We have integer types, we have floating point types. We've got also a type called void. Okay, as you can probably guess, void doesn't do anything. We then have things that can modify the types. So with integer values, we can have signed or unsigned, okay? Can the integer be minus or not? Can it be negative or not? Depends on if it's a signed or an unsigned, okay? We can then change the size in memory of particular types. So an integer we define to be a whole number. We define what plus and minus is, okay? We can then modify that definition of integer by saying it's either signed or unsigned. We can then modify its size, so as everyone should know, integers have a maximum size. Okay, it depends on your computer. We can modify that to say that they're either short, so it doesn't use very much memory, it's long, okay, it uses some more memory, or it's long, it uses a lot of memory. Okay? The reason why I'm not giving definite values to how big short, long, and longs are is because it depends on your computer. Okay? Then we can construct new types using special operators, so declarative operators. Okay, we can define pointers. Pointers are a type themselves. We can define a pointer to an int by using int star. References aren't actually strictly types. References are aliases, okay? But we can define what's called a reference, okay? References, if you haven't done C++ before, references are like pointers, but they're not pointers. References are basically aliases. References allow you to, instead of having to look at the memory address or something, it knows to go straight to the value, okay? Arrays are types themselves as well, okay? And then again, we come back to user-defined types. So all the containers that you build yourself or other people have built in particular libraries, okay? So let's look at Booleans some more. Booleans have two constants as their values, either true or false. But then you can do some sort of type conversion. So you can convert the number, say 10, to a Boolean, and that becomes true. So anything that's not 0 becomes true. Anything that is 0 becomes false. You can then convert a Boolean back to a number. So when something's true, converted into an integer, it becomes 1. And when it's false, it becomes 0. Okay? This might seem really basic. Okay? It kind of is. It's also important stuff to know, though, because you wouldn't normally associate true with 1 and false with 0. That's something that somebody's made up. That's some rules that some people have made up. Okay? So you need to get an understanding of how these rules work. Because this is where it starts to get fun. We get to characters. In C, you would have just used a char. In C++, we have lots of different types of chars. Okay? Now, it's not strictly one of these that you should use and one of these that you shouldn't use. Okay? It depends on what you're doing with them. So chars themselves, which you think are just character values, A, B, C, D, as you'd know, convert back to numbers underneath. Okay? So an A, I think, is 65 off the top of my head. Okay? But that depends on the character set I'm using. Characters themselves can be signed or unsigned. That's probably quite weird because you wouldn't think that you could have a negative A. Okay? But you can. Don't do it. Okay? But you can. So you need to be aware you can do these modifications. You also have things called W chars and char 16s and char 32s. Okay? I'm not going to give you exam questions on name all the different types of chars. Okay? That would be stupid. Okay? But be aware, if you get a cryptic error message, it might be that you've got confused over what char you've used. Okay? Let's talk about ints. So I'm going to go straight to this slide. There is a lot of different types of ints. Okay? And as you can see up here, there's the C++ standard, and there's LP32 and 64 and so on and so forth. Okay? Those are Windows and Mac and Linux implementations of these things. Okay? So you get down to like these 32-bit ones here, or these 16-bit ones here, and some computers think they're 16 bits. Some computers think that these particular types of ints are 32 bits. Okay? Again, it depends on architecture. Okay? So this is the thing to be aware of. Okay? Well, if I jump back up to the previous slide, okay? There is some guarantees on this. Okay? So the C++ standard guarantees that a char is 1 byte of memory. Okay? So a char, signed, unsigned, no, just a char is 1 byte of memory. Then a short, okay, which is an integer type, okay, is going to be bigger than that. And an int is going to be bigger than a short, and a long is going to be bigger than the int, and the long is going to be bigger than all of the above. Okay? So you can use the standard to guarantee the sizing of certain things. Okay? But the reason I'm showing you all this is don't think that, oops, something is 32 bits, okay? I'm going to go in and modify just for individual bits and pieces of things, and that should all work, okay? It's about doing dumb things. Don't go and modify the individual bits of integers, okay? Unless you very much know what you're doing, because if you move that code to a different system, it won't compile or it won't run or it won't do what you're expecting it to do. Okay? And the same applies to floating points, okay? So we've got things called floats, things called doubles, things called long doubles, okay? They differ. And again, we've got a big table showing all the different values that these things can have, okay? Now, the reason I'm putting the tables up is you shouldn't have to go and consult these tables, okay? It's just to get the idea that when we talk about a particular type, its implementation depends on the architecture of the system that you're using, okay? So general advice is use doubles. Okay, just use the word double instead of float. Okay. I've got some slides coming that will explain what ones you should just use as a rule. Okay, but just be aware of these problems. So how do we find out on a particular computer what the limits of things are? Here's a very simple piece of code that allows you to do it. Okay. And again, this is just set up as a demo. You wouldn't probably ever need to write code like this, okay? But here we go. I'll actually put some extra lines into this. So let's see what the max value of an int, what a short, what a long, and what a long looks like. Okay, so this is a 64-bit Ubuntu system. Okay, so I've made num limits. Here we go. So if you look down the bottom of here, an int by itself is that value. A short is that value, and a long is this value, and a long is actually the same size under Linux, under my system, as that one. Sorry, long is the same as a long under Linux, but it's not guaranteed. So you can use, again, something in the standard library, okay, this thing called num limits, numeric limits, to work out the size of something, work out the range of something, okay? Now, the reason why you might want to do that is, say you wanted to loop over all the values that an int could possibly be, okay? You wouldn't do something like this. Okay, this would be a very dumb thing to do. For int I equals 0, I less than 500 increment I. Okay? Oops, it didn't crash. Okay, I'm going to change this to this value here. Okay? That would be dumb. That's why you'd use something like this numeric limits to allow you to not go over the size of this. Okay? So that loop there would ensure that you go through every value of I possible if you need to do that. Okay? Every int value possible. Okay? And that would ensure that things wouldn't break. Okay? Okay, so let's talk about literals. Okay? So a char, a bool, and a int, and a float and a double and all those sort of things are values that we can put into things. We also have literals. These are whereabouts things don't change. Okay? So if we write true, that's not strictly a bool. True is just a literal. If we write speech marks hello world, sure, this gets converted into a string, but this is not a string, it's a literal. Okay? We cannot change that hello world unless we change it in code and recompile it. Okay? So there's ways of expressing literals. There's ways of expressing literals for characters or integers or floating point numbers. Okay? So let's be aware of that. Okay, so general advice on deciding what types to use. Generally use unsigned for non-negative values. Okay, so if I come back up to my num limits up here, I should have put the word unsigned in front of that. Oops. Otherwise, I potentially would have had a bug there. But then, because I've changed unsigned there, I need to go do it over here. Okay. Use int for adding, as you can imagine. Use double for floating point values. Use char bool to hold characters or true and false values. Do not be doing true or false with an int being 0 or an int being 1. Okay. And then be aware of void. Okay, so the general place we use void is when we're returning void. Don't do void star. Don't do void star pointers. Okay. We've got other ways of handling pointers and stuff in C++. Okay. Now, one more piece of code or question to you guys. I have a very simple program on the left-hand side. Okay? What do people think the output of this application is going to be? Okay? I have a signed int, so just basing int, that I've said is -1. I then have an unsigned int, b, which is 1. Okay? So -1 times 1. What's the output? Anyone want to guess? 0. Who thinks, okay, so -1 times 1. Who thinks it's going to be -1? Who thinks it's going to be 0? Who thinks it's going to be +1? Who thinks it's not going to compile? Who absolutely doesn't have a clue? That's the answer. 42949679295 is the answer to that. Okay? I actually think I've got the code to show you it. Let me just double check. So basically what happens is, as you can see in the explanation, for -1 is promoted to an unsigned int, okay? And so the -1 in the binary had 1 and a whole lot of zeros and a 1. It got promoted to an unsigned int whose value is this huge number. Then we multiply that by 1, okay? And that will not give you an error message. It will compile perfectly fine, even with warnings on. There you go. Okay, so I've got the code here, mixedints.cpp. Okay, I'll show you it works. Okay, so it compiles, and it runs. Okay, there's the output up the top of there. Now, just let me double check. Now, the reason why I highlight that is there was my compile command. Compile with C++11, give me all warnings, give me all errors, compile. And it compiles, it doesn't warn me, it just says it's fine, because it's perfectly valid C, or C++, perfectly valid, okay? So you need to be very aware of these sort of challenges that you can get into, okay? Also be aware of your expression order, okay? When we talk about expression order, that's like doing pluses and minuses and multipliers and double equals and things like that, okay? There's a whole list of operators and the order in which you can do operators in, okay? But some of these things are undefined, okay? So if I flick up to this previous screen here, saying int I is equal to 2, that's fine. Saying that j is equal to, well, I is equal to 3 times I is equal to j, that's fine, that works. Outputting, but then, well, when I say it's fine, that works, what doesn't actually make any sense at this point is, does this equals happen first or does this equals happen first? It's actually not defined. So you'd assume that I being equal to 3 and then times by I would make it 9. But that might not happen. That I here might get substituted in there, so it becomes 2. That becomes 3, that equals 6. And so you don't know. You also don't know things like this. An array of integers, obviously, so AI plus I++ is undefined. We don't know what that means. Okay, yep.
When you say you don't know, does it mean every time you run it, it will do something different, or does it mean from system to system?
What it means is in the standard it's undefined, which means that for compilers we'll have different interpretations of this, which means that when you compile it on a particular system, it will work fine. You move that code to a different computer, and it might not work anymore. That compiler might compile out to a different thing.
What level is this happening at?
Sorry?
What level is this happening?
It's happening at the compiling stage. Well, because it's undefined in the standard. So it's undefined. If the standard says this is the order that thing's happening. Okay, if you look at this here. So the order works downwards, it doesn't work acrosswards. So those ones at the top are all equivalent. And so we don't define the order in which those ones will happen. Okay? So there's a whole lot of problems that you can get into here. Okay? Now, at this point, do we want to stop for 5 minutes? Take a break? Yes? Yes? Yeah? Overload your mind? Yeah. Okay, so 5-minute break, okay?